We will solve problem 17 of chapter 16 of Ncert. This is based on the concept of induced electric field, and this is a useful concept if you have a ring placed in a magnetic field which is varying. This magnetic field is changing. Then there is an induced electric field which is along the entire path. If you integrate it along the entire path, there is an induced electric field. Its value is equal to minus d phi b upon dt. That is rate of change of the magnetic flux. And this electric field will be like in this, tangential to the path all through. And another property of this electric field is that we know that electric field produced by a charge q. When we see that electric field 1 upon 4 pi E0 q upon r square at a distance r, this field is conservative. But this field is non-conservative. So that is why this integral along the complete path does not vanish. So that is the basic difference with the conservative field and the non-conservative field which we have. Now let us come to the given problem. Here the magnetic field is given as B is equal to minus B0 for R less than equal to R and is equal to 0 otherwise, means no magnetic field in this region. No magnetic field is there in this region because R is less than R and B is equal to minus B0K for R less than equal to A, and this radius is A. Radius up to here is A. So what is the flux? Flux will be only for that area. Please note, don't take whole area. Do not take whole area. This is important. Do not take whole area. Flux is only relevant where the magnetic field is there. So take only the inner area, which is pi a square, and multiply it by minus B0K. And in fact, if you look at the concept of area, if this is the area A, then the area unit vector is pointing upwards, and in this case the magnetic field is given backwards, B0. So the product will be negative. So phi b is equal to minus pi a square B0 is the value of the flux. That is the magnetic flux. Now we have to see what is the change in flux. Now change in flux delta phi is equal to phi 2 minus phi 1, and this happens, let us see, in time dt. So d phi upon dt, because we are told that the magnetic field is suddenly switched off, we have to find out at that point of time what will be the force which will act on it if the charge on this is lambda, charge per unit length. So we have to find the force which is acting on this rim. Now we have to first find what is the electric field, what is the induced electric field along this rim. We have to find the induced electric field here. Induced electric field is how much, that is important. And for induced electric field, we need to know first what is the flux, state of change of flux, and that would be phi 2 minus phi 1 upon delta t. Phi 2 is 0, so because it is switched off, and phi 1 is minus, this becomes plus pi a square B0 upon delta t. So d phi upon dt is coming as, which is nothing but E dot dl line integral minus is equal to pi a square b0 upon delta t is your this value. Now what is the value of E dot dl? E will be constant because it is at the same radius. So E, and what is dl is 2 pi capital R. So this is the value of E dot dl. We can place it there. So minus E 2 pi R is equal to pi a square b0 upon delta t. This is one relationship. Now what will be the force? Force is equal to charge times the electric field, and in this case you have to see, take a small angle d theta. This is radius r, this is d theta, this will be r d theta. So charge here will be, dq will be r d theta lambda here, and the electric field is like this. So what is the force dF acting on this small element is E times r d theta into lambda. This force is giving a torque. So the torque acting because of the electric field on this small stretch would be equal to r times E r d theta into lambda, and this r times E r d theta if you integrate along the entire path, it becomes 2 pi r. This is basically the circumference of this outer. This is the inner area where you have magnetic field, and this is the rim. This is nothing but the circumference of ring. So this is 2 pi r, r times E, and into lambda is your total torque. This is your torque which is acting in this region. So this is your torque. Now what is the value of torque is, actually this is a very useful problem because you have multiple concepts here. Torque is equal to I times alpha. I times alpha means delta omega upon delta t, rate of change of the angular velocity, and this is how much final angular velocity be omega, and initial is 0 upon delta t. So value of torque is I omega final upon delta t, which is equal to r times 2 pi r e into lambda, because we have put the torque value from here. This is the value of torque. Now it means, and what is I? I is mr square upon delta t into omega final is equal to, what is the value of 2 pi r e? This is equal to minus pi a square b0 upon delta t into r into lambda. So value of omega final is coming as minus pi a square b0 lambda upon mr. Let us check the values again. What is getting cancelled? This is getting cancelled with this, and this remains. This is here, a square is here, b0. It is better check all the values in the end so that there is no mistake left. This gets cancelled, this comes here, and r also comes here. So yes, this is the value of omega final, and you know omega is the vector, and it is minus means basically it is pointing towards. So if you see, this was your area where we were concerned. This is positive side, positive k, and this is minus k, and you can see that electric field was working in this direction. The electric field was working in this direction, and we finally get this value of omega. So modulus of omega